Okay, I'm going to go over a combined gas law example for you. Before we left, we did the first three gas laws, Boyle's and Charles and Gay-Lussac's. This is the only one that we didn't go over besides the ideal, and we'll do that when I get back. But just real quick, I'm going to work an example. It is very, very similar to the ones that you already know how to work. Okay, so let's set this up. Here is our formula right here. It's also on the board. It always will be. You'll have access to that. Remember, I want you to write your givens. So P1, V1, T1, P2, V2, and T2, okay? Want you to write your givens. There's just more with these. There's just an extra, okay? And if you read your problem, it has a volume of 500 ml. I know it's volume because of the units. Remember, that's what tells you. So I'm going to plug that in right here. 500 milliliters. 77 degrees Celsius. Okay. 600 torr. All right, calculate the temperature if the volume decreased to this. So here's my other volume, 400. All right, pressure increased to 1 atm. Okay, so let me show you something. I know that this is 1 atm. That's my given. I can't have two different units, but I'm just really lucky because they happen to give me 1 atm, which is equal to the standard pressure of torr. So instead of having to set up my box and convert, I can just simply say that 1 atm equals 760 torr. Now, I would not have been able to do that if it hadn't have been the standard pressure 1 atm. Anything else, I would have had to have set my box up and converted that pressure. But since it was 1, I can just say that equals 760. All right, the other thing that you need to do is you still have to add 273 every time you do a temperature. Okay, so real quick, 350, you have to use Kelvin. That is still a thing. It always will be with gas laws. You have to use Kelvin. This is what we're looking for. All right, so there's all my givens, and they're all set up. My units are good, and they're ready to plug into this. So P1 is 600. So look, I'm taking this right here, and I'm plugging into it. All right, P1 is 600. V1 is 500. T1 is 350 equals. P2 is 760. V2 is 400. And we are looking for T2. Okay? If you will go ahead and combine these like terms up here, it will instantly turn your combined gas law into a Charles or Gay-Lussac's law instantly. So I'm going to go ahead and combine these. That means multiply them because that does mean to multiply. So I'm going to go ahead and say 600 times 500. That's a really big number. Okay, so 1, 2, 2, 3. Okay, and I'm going to go ahead and combine these also. So I'm just multiplying them together so that it's easier. And yes, it'll be big numbers, but it's okay. Okay, so now I can work with just these one numbers up here. And since I've already combined those, look, this instantly turned into a Charles or Gay-Lussac's, and you guys have worked several of these, so no big deal. So now I can bring this up and across. Remember I told you rewrite your equal sign, okay? I can bring this up and across, and I have 3, 0, 0, 0, T2. See, up and across. And then over here, I would have 350 times 304. Okay, and then to get T2, you just divide over, just like our other ones. Okay, so I'm going to do this real quick, and you can stick it. I would highly encourage you to put this in your calculator too to make sure that you're getting the same thing and you understand. answer is 355, and that is in Kelvin. Remember, if it asks for it in Celsius, you'll have to subtract 273 from it. But if it wants it in Kelvin, you can leave it just like that. Okay, and this is how all the problems on your worksheet work right here. Use this example to work them, and they all work just like this. But the only trick to combine is you now have 2 instead of 1. But once you get it set up, if you will just combine these two, get your big number, then it'll work exactly like a Charles or Gay-Lussac. So really no difference, just a few more numbers to deal with.